Okay, so I'm going to demonstrate convection cell. I have a container of water here that was sitting at room temperature. I have a huge hunk of ice floating on one end, and on the other end, underneath, I have a cup of very hot water sitting in a styrofoam cup. What I'm going to do is I'm going to add some food color so you can visualize what's happening with the water. Over the hot spot, I'm going to put some red food color. Okay. And then over the blue, I'm going to put some, over the ice, I'm going to put some blue food color. Oops, I want the ice to stay on this side. Stay there. So notice what's happening. So as water heats up, heat is just kinetic energy, right, of the molecules. So the molecules, as it heats up, it gains energy. It has more kinetic energy. And that means the molecules are moving around more. If they're moving around more, they take up more space. If they're taking up more space, it makes them less dense. And this is the reason why things that are warmer are less dense than things that are colder. And as the water cools down, or air too, water or air, it has less kinetic energy and molecules are moving around less. If they're moving around less, they take up less space. If they're taking up less space, they become more dense, and that's why they sink. Right? So this happens in the water, like ocean currents. This is what creates ocean currents. This is what creates atmospheric currents, right? And this even happens in the interior of the earth. Right? So notice over the warm area, the water is rising as it hits. So it looks like the layer is actually over here, but as it goes up, it starts to cool down, right? In the atmosphere, they'll actually hit the top of the stratosphere, and it will spread out. And as it's doing that, it starts to cool down. And as it cools down, it will start to sink. And as it sinks, it creates an area of high pressure because you have all this air sinking, and you have more air here. So that's region of high pressure. And then in the area where the water is rising, where the air is rising, it creates an area of low pressure because you're basically taking away that air. You're creating an area of low pressure. So you have area of high pressure, you have area of low pressure. Air always moves from high to low, and this is what creates a convection cell in the atmosphere. The Hadley cell is between the equator and 30 degrees north and south. The equator, the surface is warmer because it gets more sunlight. The warm surface heats up the air above it. The air rises, goes north or south, cools down, comes back down around 30 degrees north and south. And that movement of air along the surface is what creates the winds, those global winds. These are the trade winds. Okay. In the ocean, you also have something happening as well. In the poles, you have formation of ice, which leaves behind salt. And salt is more dense than regular water, or salt water is more dense. Plus, it's very cold, so you have this very cold, salty water sinking. In the tropics, you might have a lot of rainfall, so it makes the ocean less salty. And it's also warmer, so you got warm, less salty, so less dense. right? And so you have water sinking, moving this way, water moving this way, and it creates a convection, ginormous convection cell in the ocean. And as it's moving, it's taking all that nice warm water, the heat, with it, carrying all that heat across the ocean. Right? It's responsible for a lot of the climate along coastal areas. In the Earth's interior, you also have convection cell happening because its source of heat is the Earth's core, or maybe parts of the mantle. And as these molten rocks become less dense as it heats up, it goes up and creates convection cells. These convection cells can also happen more locally as well. You have something like sea breeze, where you might have the ocean being warmer and the land being cooler, right? And you have so that would be a land breeze, because then wind will be blowing from so you have sinking air and wind is moving away from land into the ocean. Opposite could happen if the ocean's cooler and the land is warmer, right? As the air is rising above the land, because land heats up more than the ocean water, you're going to have air coming in from the ocean. So it makes this big convection current as here as well. Right? So that's what creates movements. Air breezes, global winds, even local winds are created by this differential heating, right? Some places are warm, some places are cold, creates more or less dense air or water above it, creates these area of low high pressure and moves things around. Looks like a painting. How's that?